is one of the most important topic, right? In C language, because it is not only important, somewhat people are scared of pointers also, which entirely depends upon the perception, right? You see, you will find that if you go to a certain teacher and you join a maths teacher who teaches you integration, and at the end of the day you find that you are not able to understand anything, right? And the entire chapter, after the finishing of the chapter, when you are solving the problem, then you face the problem that you can't solve any particular sum, right? So then you realize that whatever class you attended is fruitless and you are not being able to solve one particular problem, one single problem. So you see, and suddenly, suppose next class you change the teacher and go to some other teacher, and he takes the class, and after the class he tells you to solve n number of problems, and you find that all the problems you can solve by yourself, right? So what is the difference? The difference is perception, right? A teacher is supposed to give his perception about the topic to the student, right? Now if his perception is easy and and can be understood by the students, then automatically the entire chapter of the topic becomes easy for the student. Otherwise, if the perception is not properly portrayed in the class, if a wrong perception is given or a perception which is difficult to absorb or understand, then the students don't find the chapter interesting or understandable, right? The same thing happens in case of pointers. Pointers is one of the most important topic in C language. You not only have pointers in this semester, but those of you who will be doing data structure and all, the future studies using C and all, especially the IT and CSC background people, they will require pointers in case of data structure also, right? Because in data structure you have topics like linked lists, trees and all, where there is a huge application of pointers. One more thing is that the entire idea of pointers, as portrayed by authors also, teachers and authors, when they start with pointers and all, they keep on saying that pointers are a difficult topic. When if, like suppose in most Indian author book, if you find the chapter of pointers, for the chapter of pointers, the first page, the first paragraph, first line will go like this: that pointers is a very, very difficult topic. It is very difficult to understand and be very careful and blah 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 blah. So automatically, reading the first line only, the student comes into a negative frame of mind that it is something that is beyond my capability. I won't be able to understand properly. So if I read the chapter 10 times also, God help me, right? So it is not like that. Pointers are easy, right? If understood properly, they are easy and they are fantastic tool for a program. You see why pointers are so important, right? Why do you think pointers are so important? The application of pointer is directly connected to the memory. I'll give an example. Let us say that if you ask a chef or a cook that what is more important for him, whether the kitchen is more important for him or whether the dining table is more important for him, what will he say? His response will be the kitchen. Why? Because if everything goes properly or goes well in the kitchen, then the proper food will come up on the dining table, obviously, right? So if something goes wrong in the kitchen, then the food will be proper, right? So from the perspective of a chef or a cook, the kitchen is more important than the dining table. Similarly, for a programmer, the memory is more important, because memory is where you actually work, and correspondingly the output is your dining table, where you serve the output, right? So output, we are not that much concerned about the output, because we know that if the data is being processed properly, if you are being able to process the data properly, then it is obvious that the output will come anyways, right? So pointers basically help you in managing memory. This is the most important feature of a pointer. That is, in pointers, then automatically you will be able to handle memory in any way you want, right? So that is why pointers is such an important topic. Now, one more thing is that since you are doing C language, you have already done a lot of topics beforehand, and later on you will be structure, data file handling, and all the other topics. You will find that once you go for an interview or something, if you go for an interview, and the person who is taking the interview, tell him that you know C language, right? Your entire knowledge of C language is somewhat directly proportionate to the knowledge that you carry in pointers. If somebody tells me, suppose I am taking the interview and somebody comes and says I know C language. So I as a person who is taking the interview, I will look forward to how much the person knows about pointers, because that will, you know, satisfy me completely. That is, if I find the person who is, you know, who says that he knows C and his knowledge about pointers is sufficient, then I know that okay, fine, this is a proper guy. So that way also pointers is very, very important. You will be reading pointers in C language, you will be reading pointers in data structure, you will be reading pointers before your campus placement, you will be also reading pointers when you join the company during your training. So this is a very, very important topic. Just like other topics also, but this is more conceptual in nature. Right? Now, let us define what is a pointer. As you can see, pointers are special variables used to store or manipulate an address of a memory location. Right? So, which means that pointer is a variable. It is just like any other variable. The only difference is that in a normal variable you put the value, but in a pointer variable you assign an address. Now you see, this is something that is there in most of the books also, apart from a small fact that, you know, when you read any book, normal books and all, you will find that the definition is a little bit different. They say that pointers are special variable used to store or manipulate an address of another variable. Right? I have written of a memory location. Usually you find daylight address of another memory variable or another variable. There is a little bit of difference. You know, you can actually have a pointer which can point to any byte or any memory without having any, you know, formal variable declared in that particular point. Even if there is a variable or not, you can actually have a pointer address. So that is why my definition is a little different. That it is not necessary that you have a variable and then you can use a pointer on the memory. But without even creating a variable also, you can assign a direct address to the pointer. So that is why I have not mentioned memory variable. I have generalized it. I have said memory location. It can be any memory location, right? Now you see, suppose if I tell you what is an int. When I say int a, if I write int a, right? If I declare a variable called a, I say int a. I hardly have to make you understand the properties of it. Why? Because you are from maths background. You automatically know the properties of integer and can directly associate or map the properties that you have learned in maths with the integer variable, which means you don't actually have to, I don't actually have to make you understand anything regarding integers. You automatically know that what a can contain and what a can be used for, right? But with pointers, I have already mentioned that pointer is a special variable which will contain the address of another memory location, right? Now, unless you know what is an address, you won't be able to understand what is a pointer. Because if a pointer contains an address, first you must find out or understand what is an address in the first place. If you have got no idea what is an address, you won't be able to understand pointers in the first place. So you see, memory or the RAM part is comprised of bytes. Each byte is numbered, right? Each byte is numbered sequentially. Like suppose there can be a 0 byte, there can be a 1 byte, 2 byte, 3 byte. Sequentially it is addressed, right? Every byte is associated with a unique number. That unique number is called the address. Now what is the advantage of using an address? We all know that, you know, since we have already done functions. Suppose if I say that main is main, where I can have an int n. I can even have a global variable called n. I am calling a function from main which will take me to the function, say void fn, and inside fn I can declare another variable called n. Now when we make the students understand this kind of program, we make boxes, right? We make a box for main where we allocate the variables for main. We make a box for the function, and we allocate space for the function. And you automatically can differentiate by looking at the diagram. You can differentiate. Okay, fine. This n belongs to main or this n belongs to function. So suppose if I say this is global memory, this is n in global memory. This is n inside main, local n inside main, and this is fn, another n which is locally declared inside the function. Then the function is called, right? Now you see, memory is not a wide, right? So the compiler or the instruction that is getting loaded or executed in the memory, it can't actually draw a line inside the memory. You can't. Memory is not a whiteboard, right? So it is made of bytes. So how does the compiler understand or differentiate between the various n that you have declared? So each of these n, when they are declared in the memory, will be having different address. Suppose this may be at 300, this may be at 400, so this may be at 200, right? That is how variables are differentiated. Not only variables, but everything inside the memory that you are declaring, when it is loaded in the memory, it will contain some address. And it is by the address that each item is distinguished or differentiated internally. So addresses are there in the memory to differentiate bytes or distinguish between bytes, right? So what is the definition of address? Address is a unique unsigned integer, right? An address is a unique unsigned integer which is hexadecimal in nature, associated to each byte of memory. It is by this unique number that variables are identified in the memory. Not only variables, here I have generalized upon, and I have been specific about variables, but it can be an array also, it can be a function also, or anything, right? Anything that you declare in the memory will consume some bytes, and if it consumes some bytes, then those bytes will have a unique number called an address. Now the properties, let us justify the properties of an address. Addresses are unique, so obviously that is the only advantage of having an address, right? To differentiate, we use unique number. Now this system of using unique number is, prevalent in every sphere of life. Suppose if you go to the college, are you personally identified by your names? No, you are personally identified by your roll number or index number or whatever, right? So why? Because two people can have the same name. So we resort to numbers to differentiate between two persons, right? Two or more persons, right? Similarly, if you think of the license plate of a car or a vehicle, right? They also contain numbers. Alphanumerical code is there, alphabets as well as numbers, but usually numbers are required, right, to differentiate between two cars or two vehicles, right? So similarly, wherever we find that it is human nature only, wherever we find that there might be a conflict, we assign a unique code. So similarly, every byte has an address which is a unique code for that particular byte, and it is sequential in nature. That is, every byte will have, the address of each byte will be incremental order, right? It will be unsigned. Now you see, we are at 30A Southern Avenue. We are at 30A Southern Avenue, right? Minus 30A Southern Avenue does not make any sense, right? Address is supposed to be what? Absolute. So it is unsigned. That means address can never be negative. It is integer, which is also very obvious. If we are at 30A Southern Avenue, right? The next neighbor might be either 29 or 31. 30.5 does not make any sense. So addresses will never be fractional. They will always be a integer, right? Internally, when you are working with an address, internally it is represented by a hexadecimal number. Why? Because hexadecimal numbers are shorter and easier to assign. Example: if I want to assign an address to a pointer, I can write a star p equal to 0x. This is the hex code, right? This must be given. Once you give 0x, the rest of it is treated as a hexadecimal number. So 0x, then you can write ff2a, right? So ff2a is the address where p will be pointing to any particular address, right? So you see, 0x must be given as a prefix, ff2a is the address that we are talking about, right? Now ff2a, we know that each hexadecimal number is actually, contains 4 binary digits. One place in hexadecimal is equal to 4 binary digits, which means how many binary digits are there? 16. Which means that an address is comprised of how many bits? 16 bits. If an address is comprised of 16 bits, that means 2 bytes. So the pointer is also of 2 bytes. In C language, 16-bit C language, we have 3 types of pointers. Right? We have got 3 types of pointers. We have got a near pointer, which is made of 2 bytes. We have got a far and a huge pointer, each of which are made of 4 bytes. But in your course, specifically you have near pointer, and near pointer is what you should start from. Later on, at a later point of time, right, you can study it by yourself also, the far and the huge pointer. But near pointers is what we are focusing on. So near pointers will comprise of 2 bytes. Please remember that. That is, each address is of 2 bytes, and the pointer itself is also of 2 bytes. Associated to each byte of memory, it is by this unique number that variables are identified in the memory. So each variable is identified by this unique number, each variable, array, function, whatever. Now I have told you what is the address. Now how will you find out the address of a particular thing? So for instance, working with the address, for instance, int a equal to 5. Right, so we have declared a variable called a, now which contains 5. Right, we are assuming that the content of a is 5. So since A is an integer type variable, tell me how many bytes will it take? 2 bytes. It will occupy 2 bytes. So let us assume, right? Because we can't decide upon which bytes will be allocated. It is like, going into a hotel and you want to stay in a hotel. You can't say that, okay fine, I want to stay at room number 20. If there is somebody staying at room number 20, please kick him out. You can't say that. Similarly, while declaring variables also, we can't decide upon which address it will take, but 2 bytes will be allocated and whatever address is generated can be fetched, right? So suppose if I say int a equal to 5, then a will comprise of 2 bytes, it contains 5. So I have assumed that the starting address is 200, which can be anything, right? Now for convenience sake, I am showing the address in decimal form for our convenience. Internally it is accessible. So let us say if the first address, the first byte address is 200, it is obvious that 201 will also be under use. Why? Because if int occupies 2 bytes, then 2 consecutive bytes will be dedicated to the variable called a. Right? Now the content of a is 5. The first byte address is 200. The second byte address is 201. Later on, if I say printf %d, %q, a, ampersand b. So we all know that when we write %d with a comma a, we get the value, right? So which is in this case 5. But suppose if I write %q and ampersand a, ampersand stands for the address of operator. It stands for the address of operator. When you say ampersand a, it will generate the base address of a or the beginning address of a. So in which case you get the output as 200. Now why are we printing the address as %q? %q stands for unsigned integer, right? Since we have already discussed that an address is unsigned, so it is a better idea to print it in %q form, because if you print it in %d form, the address generated might be negative. Because in %d form, you can't go beyond the value 32,767. If you go beyond that, you start generating negative numbers. Right, so an address as 40,000 will actually show you a negative address. It will show you a negative address. So it is a better idea to use either %d or %x. In case of %x, it will show you the exact hexadecimal address. %x stands for hexadecimal. Fine. So in this case, we get the base address 200. Now, since I am saying ampersand a, why am I getting 200 and why is this 200 so important? You see, this 200 for any allocation, an allocation might be of 2 bytes long or 10 bytes long or 20 bytes long. The first byte address is very, very crucial and very, very important, because the first byte address is known as the base address. Why is it so important? For obvious reasons. Suppose if you open a book, when you open a book and you are going to the contents page, you will find the chapter name given, and along with the chapter name you find the first page number. Do you find all the page numbers? You don't find all the page numbers. Why? Because you already know if you can write up on the first page, then you read the rest of the chapter sequentially one page after the other, right? Similarly, if I say that a variable starts at 200 and it is int, so it is obvious it will take 200 and 200. Now suppose if I say a variable which starts at 200 is float, it is obvious that it will take 200, 201, 202, 203. Got it? So that is the reason why the first address is so important, and that is why we give it a special name. We call it the base address. So the base address of a variable can be fetched by the ampersand or address of operator. A occupies 2 bytes. Since it is an int, the address of the first byte is the base address. Now what we have done right now is we have printed the base address of A, which if you think carefully, as far as software development is concerned, is quite irrelevant. I'll tell you why. See, we write programs which are to be used by whom? End user. End user is non-technical. He does not know anything about computers, programming or whatever. He can just operate a software, right? He is not concerned about C language, he is not concerned about what is going inside the memory, he is not concerned about where you are keeping the answer. Now suppose if I give you an example, you have been told to find out the symbol interest for the layman or for the user. Now you will accept the value of PTR, you will find the value of SI by writing SI equal to PTR by 100, P into T into R by 100, right? You thus get the value of SI, let's say which is 500. Now the user, think about the user's point of view. From the user's point of view, 500 is important, the value, the answer. But suppose if the 500 result is stored at FF2A and you are printing that also, the simple address is 500, which you can find at the hexadecimal address 0xFF2A. We'll freak out. because he does not require that information. He doesn't require that information, right? So you see, printing an address is of no good use generally. This is a demonstration that I'm giving you that how you can fetch an address and all. So this is a demo you can see. But otherwise, addresses are never printed. They are worked upon. And in order to work upon something, we generally, what do? We store it in a variable. Now suppose if I tell you that you have 5, you add 2 to 5, you add 10 to whatever you have, you get 17 and thus and that. So you always think of a calculation in terms of variable. Okay, fine. A equal to 5, A equal to A plus 2, A equal to A plus 10 becomes 17. Fine. So suppose if I tell you that I want to work upon this address 200. So first thing that will come to your mind is that I have to keep that 200 in a variable. Money, we are talking about assigning this address to a variable. Now, in this entire course of this, during this entire class, I will ask you a few logical questions. A few logical questions I will generate, I will ask, I will provide the answer also. Fine. But these logical questions are very, very important. My first logical question is basically upon the fact that why pointers exist in the language in the first place. Why are pointers there in the C language? Right. So this is very, very careful. Now you see, let us think of an address again. An address is an unsigned integer. Now normally, if I want to place this 200 in a variable, right, I can, if I want, write unsigned in B equal to ampersand. Now just think. Technically, this should work, right? Technically, this should actually work, isn't it? Because I have already told you that the address of A is an unsigned integer. So, technically, nobody should stop me from assigning the unsigned integer address to an unsigned int variable. But do you think this will work? Anybody? See, the fact is that if this would have worked, then we wouldn't be studying pointers right now. Why? Because there wouldn't have been anything called pointer in C language. B is a normal variable, so pointers are not there. So as I said earlier, that my first logical question, right, is basically the fact that why pointers exist in the language in the first place. If I know that an address of a variable or a memory location is an unsigned integer, I can assign that unsigned integer to any unsigned variable, right? Unsigned in B. So, but then this does not work, and in fact, this gives an error. This gives an error as this: cannot convert int star to unsigned int. This is the error that we get. Cannot convert int star to unsigned int. When we say ampersand A, it is supposed to generate the address 200. Now I have already told you that the address 200 is basically an unsigned integer. So I should be able to assign that address 200, which is an unsigned integer, in a normal unsigned variable. Now this does not work, and it shows this particular error: cannot convert int star to unsigned int. Now from here only we can make an approach to understand why pointers exist in the language in the first place. Why? Because since this cannot happen, there has to be some reason why pointers are there, right? Now, for the time being, just think that this will happen or this will work and this will not show you any comparison error. Mane, you must understand that what problem will this cause. Then only you will be able to understand that why this is not used and why pointers are taken instead, right? So the problem that this will cause is that suppose we say that B is an unsigned integer and B actually contains the address of it or the base address of it. So B contains 200. Now if B contains 200, if I tell you that since B is an unsigned integer, I can multiply B by 10. I can multiply, if I want, I can write B equal to B into 2. So it should become 2000. Or if I want, I can write B equal to B by 10. So it will become 20 then. Fine. So all these operations are completely illogical in the context of an address. If I say 38 suddenly, later I say multiply 38 suddenly by 10, it becomes 300 suddenly. It might not be suddenly even. You might have crossed, right? So it is irrelevant. Multiplying an address by anything is irrelevant. Similarly, if I tell you that, let us say that 38 divided by 10. It does not make any sense. Few operations, most of the operations that we actually perform upon normal integers should not be allowed in the context of a pointer. Are you getting it? Most of the operations that we usually perform upon a normal integer should not be allowed upon an address, because although an address is a integer only, but operations are not to be allowed. Why? Because they don't belong to the context. Okay, they become illogical. Multiplying, dividing, finding the remainder, all these things become illogical. That is why this is not allowed. You can never assign the address in a normal variable. You have to declare a pointer variable for that. Fine. So that was the answer basically. The first reason that you find that why pointers are there in the language is that although we know that an address is an unsigned integer, we should be able to contain it in a normal unsigned variable, but all the operations that can be performed upon an unsigned variable should not be allowed in the context of an address. So C language, the developers of C language have specifically mentioned that if you want to contain the address of a real location, then you must declare a pointer variable. Why? Because for the pointer variable, all the operations are not applicable. Few operations are applicable, but not all. And those operations are logical. Like for instance, if I say 38 suddenly, and later I say I add 1 to 38 suddenly. So I will go to 31 suddenly. So if I move on to 31 suddenly, then that makes sense. Because 31 suddenly is my neighbor, or 29 suddenly is my neighbor. But multiplying it by 10 outright does not mean anything, right? So few operations like plus, minus, you will find out later. I will show you the operations which can be performed upon a pointer are available, but most of the operations are not available. Now to differentiate, between a normal variable and a pointer variable, there must be some system by which we could understand. There should be some system by which we should understand that this is a normal variable, this is a pointer variable. And for that we have the application of star. Now let's move on to the next slide. As said, the magical star. Now the star operator. Why am I calling it magical? Is because right at the beginning of this course, I had told you that there are around 40 operators in C language, but the actual number of operations is more than that. There are many operators which have got more than one operation. Star is a very good example of that. That is the star operator. When we use star operator between two predefined data types, it becomes multiplication, binary operator for multiplication, A into B, right? The same star operator, when we use the same star operator to declare a variable, right, we create a pointer variable. That is the differentiation. So you see, if you are creating, suppose if you say only int A, you are declaring a normal variable. The moment you say int star A, then A is a pointer variable. That is how we differentiate. So further displaying the base address of A is futile because the end user is not concerned where the program is holding the value in the memory. Thus addresses are not usually meant to be displayed, but are to be worked upon. To do so, the address must first be stored in a pointer variable. Right, we must store the address in a pointer variable and then start using it. For instance, int A equal to 5, so A contains 5 as per the previous example. Then we say int star P. So when you say int star P, you are declaring a pointer variable by the name of P. Now please remember, when you say int A, int is the data type and A is the name of the variable, right? So in case of int star P, please remember that int star is the data type and P is the name of the variable. Int star is the type and P is the name. And how do we prove it? Star P is never the pointer, P is the pointer. In case of int star P is never the pointer, only P is the pointer, because you can't again declare float P. Had star P been a unique variable name, then you would have also declared float. So float P is not allowed, or int P, it is not allowed. Why? Because P is the name of the pointer and int star is the data type. So int star is the data type and P is the name of the pointer. Right, and why this thing has come is because why the star has been put, because star will tell the compiler that whether the variable that you are creating is a pointer variable or not. If you write only int A, then that is a normal variable. If you say int star P, then P is a pointer variable of int star type. So int star is the type and P is the pointer variable. Now you see, as per this argument, since we have declared a pointer called P which will contain the base address of A, since we have declared a pointer called P which is supposed to contain the base address of A, our next logical step should be P equal to ampersand A. Our next logical step should be P equal to ampersand A, and this should be compatible. Now this should be compatible. So we know that ampersand A generates 200, and we know that the data type of P is int star. So we can say that the data type generated by ampersand A is also int star. Meaning this address 200, the data type of 200 is also int star. You see that unless the right hand side matches the left hand side, it can't be assigned. So think properly. When I say P, what comes to your mind? When I say A, what comes to your mind? Int. When I say A, what comes to your mind? Data type of A is what? Int. When I say P, what is the data type of P? Int star. So if I am being able to assign ampersand A to P, please try to register this. Okay, if I say P equal to ampersand A, I am assigning ampersand A to P, and the data type of P is int star type, then it is obvious that the data type of 200 is also int star. When ampersand A, the data type generated by ampersand A is also int star. That is why they are compatible. So now you will be able to understand why this error had come. In this case, in the previous case, when we had written B equal to ampersand A, it gave a particular error. It said cannot convert int star to unsigned int. Are you getting it? Cannot convert int star to unsigned int. Why? Because ampersand A had generated 200. The data type is compatible to int star. So 200, the data type of 200 is int star and cannot be converted to or assigned to unsigned. Why? Because P is unsigned. So that is why we got this error in the first place. So one thing is again very important. You see, in this relationship, we say that P is the pointer and A is the pointing. Now the pointy, the word pointy is very rarely used, but I find it very useful. Right? It is very easy to understand by the concept of pointer and pointer. Pointer is the variable which is supposed to contain the address of the variable which is known as pointer. So the name of the variable is A. So the address of A will be contained in the pointer P. So P is the pointer and A is the pointer. This is the relationship, right? So now we are at a point where we know that the pointer P contains the address of A, base address of A, which is 200. Fine. Now suppose if I want to access, why have we gone through so much of trouble? Because we wanted to access the variable A via the address 200. Fine. So we have contained the base address 200 in the pointer variable called P 200. So now I am interested in accessing the value of A by P. Right. So for that, we use, suppose if I say printf %q %b or %d %q, if I use this, right? Now star has got two U's in the context of pointers. Basically star has got three U's. Star when used as a binary operator between two predefined types. Right, between two predefined types, it is used for multiplication. Star in the context of pointers has got two U's. Star when used during the declaration of a variable, it differentiates between a normal variable and a pointer variable. By putting a star allows you to create a pointer variable. Later use of star upon the pointer, which is the unary operation. If you use star again upon the pointer, you are basically fetching the value. How? If you say star P, now when you say star P, star actually means value add. Just like ampersand, I told you that ampersand means address of, right? When we say ampersand A, it actually means address of A, which is 200. Similarly, star means value add and P. Now I will show you a common mistake that is made by everybody, which makes the problem or makes this this operation very difficult to understand. You see, Every book, every author, every teacher says that star is value added. Right? Then they say star P will give you 5. But usually lot of people can't connect this idea. How? If I say star means value add and if I say star P, then that means value add P. Now logically value add P should give me 200. But you will find that the teacher says it will give you 5. You will find that the book says it will give you 5. You find that your best friend also says that it will give you 5. So you make a short circuit in your mind. That is, I am not able to understand the operation. So what I do is that whenever I get star P, I will think 200, but I will say 5. That kind of a shortcut people usually make when we can't, possibly understand things in a logical manner. This is done by all technical people. Last moment studying, tomorrow we have I have an exam, there is a small part which I can't understand because every time I am thinking the logic is going wrong. I am thinking suppose X and what the answer is Y. So what I do is that if I think X, the moment I think X, I will say Y or write Y without understanding why I am writing. Fine. So similar thing goes with this case. Means value add. I have seen lot of people having doubt in this particular part. Star, they say that star means value add. P is P. So value add P should give me 200, but it actually gives you 5. Why? Because there is a very small but very important mistake that is happening here. You see, what does P contain? 200. So when we say star P, instead of writing P here, try to write what P contains. Now think. Value add 200. What is it? 5. Now it is solved. So star means value add. When you read star P, don't think star P means value add P. If you think star P is value add P, you will always go wrong. You will need that shortcut in your mind. Fine. So if you want to know the actual thing, you always have to substitute P by the address that P contains. So since P contains the address 200, so P contains and we substitute it. Once we substitute it, everything is fine. See, value add 200 is 5. What is the value add 200? What is the value add 200? 5. So we get the value as 5. Are you clear with this? And I will tell you an idea, I will give you an idea which if you keep in mind, you will never forget this throughout your life. Till the last day of your life, you won't be able to forget this particular concept. Why? See, this is the idea. Suppose, listen carefully. If I say that I is an integer variable and I contains 5. Think. If I say that I is an integer variable and I contains 5 and I say I plus plus, what will happen? I will become 6. So I plus plus, you are saying that I plus plus will make this value of I become 6 if it is 5. Right? I am saying that no, plus plus will make this J. Does that make any sense? It does not make any sense. Why? Because you all already know that plus plus is an operator which is supposed to operate upon the data stored on I, not on I itself. Plus plus, a plus plus operator will never actually work upon I, it is supposed to work upon the content of I. So similarly, when we say star P, star is also an operator. Star is not supposed to work upon P, but it is supposed to work upon the content of P, which is 200. So when you say star P, you say star is value add. You never say P is P. You say P means whatever P contains, which is 200. So which means value add 200, which is 5. Are you clear? You understand that properly now? You will never ever make a mistake using the star operator. Good. So that was the star operator. Right? There are two uses. Let us revise. Star operator can be used in two ways. That is, when the star operator precedes the declaration of a variable, the compiler understands that the variable declares the pointer to a certain type of pointer. Example, int star P. P is a pointer to type int. Name of pointer is P, data type is int star. Further application of star means the value add operator. Fine. So further application, when you use the star operator in a unary form upon the same pointer variable, it works as a value add operator. So that is star P means value add 200, not P but 200. So it does gives 5, which is the value of the pointer, in this case 8. Fine. So this is how you can use a pointer to indirectly access the content of the pointer. Fine. Just by doing the address. Now comes the second logical question. Okay, what was the first logical question? Why do we have pointers in C language in the first place? The answer to that was what? That in case of normal variables, all the operations are allowed for normal variables, which goes out of the context for addresses. Why? Because addresses should not be multiplied, should not be divided at all. So that is why specifically the developer of C language has designed pointers, and which are special variables, so which do not allow all arithmetic operations. Few are allowed and few other operations are also allowed, many new operations, right? Like star. So my next logical question is that, suppose I am making two parallel programs, right? So if I say int a equal to 5, fine. I know that a contains 5. Suppose base address is 200. If I want a pointer upon a, I have to declare it as int star p. And by writing p equal to %a, I will be able to assign the base address 200 in p. Fine. Suppose parallel another program where I am writing float a equal to 5, 0.0 or whatever, right? But in this case, if I want a pointer upon a, I have to declare it as float star. Now my question is that why don't we have a universal pointer, because all pointers are supposed to contain address. So a contains 5.0 and say p contains 200, which is the base address. So when I get p equal to %, the base address will be assigned. Now look at this carefully, okay? And I am asking the question right now. This shows us the simple fact that pointers are data type specific. The data type of the pointer depends upon the data type of the pointer. If the pointer is int a, then the pointer is float star p. Int star p. If the pointer is float a, then the pointer is float star p. Are you getting it? So why this? Because from the diagram itself, you can very well understand that the pointer is always containing the address. In this case also it is containing the address 200, and in this case also it is containing the base address 200. So why don't we have a universal pointer of some type? Why are pointers data type specific? That is the question, right? Now if you see, I can give you a couple of reasons. I can give you 3 reasons. The first most logical reason is that if you apply star, think, in the first case p contains 200, but we already know that the actual data is comprised of 200 and 201. In the second case also, the p pointer contains 200, but the actual data is comprised of 4 bytes. Getting it? It is comprised of 4 bytes. So just think. In this case, when I use star p, which means value at p, or see value at 200, so it knows the starting point 200. In this case also, when I use star p, it knows the start point, right? Because we are, the pointer is just containing the base address. How will it come to know that starting from 200, whether it has to fetch 2 bytes or whether it has to fetch 4 bytes? Number 1. So it comes to know from the data type of the pointer. Whenever you are applying the star upon the pointer, you are trying to fetch the value. The pointer contains just the base address, not the other addresses. So what will tell the pointer, or what will they tell the compiler that how many bytes has to be fetched from the given memory location? So in case if p has been declared as int star, it knows that p contains an address of an integer variable, so it will read 2 bytes. Fine. And in case if you have declared p as float star, right? The moment you say star p contains 200, it knows that starting from 200, it has to read 4 bytes. Now again another thing. If I write 23 by 5, what do I get? 4. But if I write 23.0 by 5, what do I get? 4.6 something. This will give us just 4. So not only bytes that are read are important, the data type is also important. See, everything that is stored in the memory is in binary form. So this pointer will read 16 bits, this pointer will read 32 bits. But what data will be composed from the 16 bits will also be decided by the read of the pointer. 16 bits are read and it is composed into an integer. 16 bits are read, 32 bits are read and it is composed into a float. How? Suppose in this case if I write star p by 5, it should give me 4. In this case if I write star p by 5, it should give me 4.600. So how will it decide what to do? Because p contains only the what? Only the base address. So what data conversion will occur will also depend on the type of the pointer. Even if two pointers are pointing to two pointees which are each 4 byte long, does not mean that they are of the same type. How? Long and float. Think of long, it is 4 byte. Think of float, it is also 4 byte. But long is a different context altogether. It is integer. And float is a different context altogether because it is real. Fine. So I have given you two answers right now. Why pointers are data specific? I have said that since the pointer contains the base address, only the base address, how many bytes to be fetched from that particular start address depends upon the type of the pointer. And what to do or what data is to be composed out of those bytes, whether those bytes are to be converted to an int or whether those bytes are to be converted to a float or double, is also decided by the data of the pointer. So these are the two answers that we give. There is a third answer also, which you have to wait for the next class because that is associated to arrays. That is movement of all pointer arithmetic. When we move a pointer ahead or backward, we say +1, it goes 2 bytes ahead. We say -1, it goes 2 bytes before. Right? So for that, let's wait for the next class, the third reason. Now let's come to the next part. You see, in the previous slide, we have already seen that by using the pointer, how do you access the pointing using the pointer? If you use star on the pointer, you get the value of the pointing. So if the base address of A is 200 and you have kept 200 in the pointer called P, then by applying star upon P, you can fetch the value of A. That is, you can read the value of A. In this slide, I am going to show you that you can not only read the value of A, but you can modify the value of A as well using the pointer. If the pointer contains the address of A, it can not only access the value of A, but it can also change the value of A, which is of immense importance. Why? Because that means we can indirectly control memory. We can have indirect access. Okay. So the value at operator star can be used to modify the value of the pointer as well. For instance, if I write int equal to 5, I am again declaring the same thing which contains 5. I say P is a pointer, int star P, so P contains 200, so P is a pointer which is pointing to A. Then if I say P equal to ampersand A, so P contains the base address of A. After that, if I write star P equal to star P plus 2, how do you work that out? So when you say star P equal to star P plus 2, it actually means value at 200 equal to value at 200 plus 2. Now, we know that all operators are, processed on a priority basis, right? First, this value at operator will work. So, value at 200 is 5. So, 5 will be fetched. Then this plus operator will work. So, that will become 7. Right? 5 plus 2 is 7. So, 7 will be assigned as the new value at 200. So, when you assign 7 as the new value at 200, the 5 is lost and it becomes 7. So after that, if you print star P and A, both will print 7. Why? Because star P means value at 200, which will print 7, and if you print A also, A has been modified, so A prints 7. Are we clear? So by using a pointer, you can modify the value of the pointer also. Now, initially, while giving you reasons and all the logical questions, my first logical question was why pointers are there in the language in the first place. Tell me something regarding that. If I say P equal to star P by 2. If you remember, I had told you that division and all does not work on pointers. That is why they are declared as pointers in the first place. Tell me, do you think this will work? Yes or no? This will work. So what won't work? Very good. Star P equal to star P by 2 will actually work. What won't work is P equal to P by 2. Star P you can think of, you can just as a shortcut you can think of as A. So when you justify, you can think like this: will A equal to A by 2 work? Yes, it will work. So if A equal to A by 2 will work, so will star P equal to star P by 2. What won't work is P equal to P by 2. Why? Because P by 2, you are basically dividing that. You are trying to divide 200 by 2. That won't happen. But 5 is a normal integer, and normal integer can be divided by 2, so this can happen. There is a lot of confusion. What will work? Because especially when we are working with pointers, we are also working with normal variables. So mixed expressions are very deadly. You know, a long expression you are writing, in the long expression that you are writing, few are pointers and few are arrays and few are something else. So when you mix those kind of an expression, you have a lot of trouble, right? So I will show you a way right now, which you will find immensely useful in understanding whether the expression that you are writing is proper or not. Fine. Now, basically we say that prevention is better than cure. Fine. So we say prevention is better than cure. So suppose while writing an expression, if you find that while writing an expression, before even you have thought of the expression or you are writing the expression, you know what is right and what is wrong. So do you think you will never make a mistake? You will never make a mistake. So but then you have to get the right perspective of writing expression, right? So let's say in order to do that, let us understand that in C language we have got predefined type, we have got predefined type, we have got user defined type, we have also got something called derived type. Now predefined and user defined type, what were the predefined types I have taught you? Int, float, cat, double and void. What are the user defined types that we have done? One that you know of: arrays, structure, enum and union. Tell me something, where did pointers go? Where did pointers go? We know that predefined types we have int, float, cat, double, void. For user defined type we have got array, structure, enum, union. There are pointers. So pointers do not fall in either one of these categories because they are derived type. Only if int is there, you can think of int star. So int star is a derivation of int, right? And so why not user defined type? Because you can have a pointer upon an int, you can have a pointer upon an array, you can even have a pointer upon a function. So pointers cannot be classified as predefined. Because if you classify it as predefined, you can how will you justify that? How can you justify a structure pointer? Or how can you justify a pointer to an array? You can't justify. So it is something that belongs to both the predefined type and the user defined type, and hence it is called a derived type. Because only if there is a basic type you can have a pointer tag to it. So pointers are called derived type. Remember this also, right? So as far as composite deriving is concerned, by composite I mean user defined type and pointer type, I will show you a technique using which while writing the expression only you can figure out whether the expression that you are writing will work or not. Fine. Now for that, please do understand, we will be using plus operator as an example. The plus operator has been designed or built inside in the language to handle few derivatives, few predefined types. If you write plus operator, what is plus operator? Plus operator is a binary operator. Plus operator is a binary operator, so it will have two operands on both the sides and there will be a plus symbol. That's it. If both the operands are of int type, it will be able to add. If one of them is int, the other one is float, it will be able to add. If one of them is float and other one is double, it will be able to add. So what I am trying to, develop out here or establish out here is that if for predefined types it does not have any problem. Why? Because the C compiler can understand predefined type. It is its own type. It knows how to add two 16-bit data, how to add a 16-bit data with a 32-bit data. It knows those things, right? But for user-defined type, it does not have. Right? Let me show you. Suppose if I write int a, b, c. Fine. So if I say c equal to a plus b, do you think this will work? This will definitely work. Fine. How do you know? Basically, the data type of A, how do you know the data type of a certain thing that you have declared? If you say int A, you can simply use the cutout rule. Okay, that is, suppose you let's say int A, you mention A somewhere, anywhere in the program, right? The context of A is taken as int. So basically, since you are using A and B, let us cut out A and B. What is left? Int. So you are applying int plus int, and the compiler can understand int plus int. Got it? Suppose if I write int A box 5, comma B box 5, we have already done arrays. So comma C box 5. So I am creating 3 one-dimensional arrays, each containing 5 elements by the name of ABC. Now tell me something. Do you think C equal to A plus B will work? Now this will never work. Why? Because at this work you would have never used a for loop. We use for loop to access each element and add each element, right? We use it like this. For I is equal to 5, I plus plus, C of I equal to A of I plus B of I. This never works. And this will give you an error, right? When you say A plus B, it is supposed to give you an error like this. Cannot perform inbox plus inbox. Now there is something very interesting and funny with C language. The type of errors you can't generally relate with the statement that you have written. You have written something else, it is showing an error. You can't associate the error with the thing that you have written. That is why you are very afraid of errors. Because you know that if it shows an error, you won't be able to understand what the error means. So how do you rectify? Right? For a programmer, this becomes very painful, right? See the programmer's point of view. He will say, I have this C equal to A plus B. In the statement C equal to A plus B, I have, nowhere mentioned inbox plus inbox. So it is showing me inbox plus inbox. Where have I written inbox plus inbox? And that too, please remember, this is a declaration which is done at the top of the program, and this may be a half a page after it. So, the association, you don't remember that when you say, okay fine, I'm adding it, it is not happening. Not only it is, it's not happening, there is a part of the thing, the kind of error it is showing me, I can't associate it with the statement itself. I can't associate it. Fine. So how do you associate it? Now normally tell me something, this would have been more user friendly, cannot perform A plus B. This is more user friendly. This error is more user friendly. So what that makes you feel sometimes that C intentionally is trying to make a fool out of us. Right? Cannot perform A plus B, you can understand very easily. So that should have been the error message. Why this so difficult error message? Right? Why not this? This makes your life simpler. Think like this. Suppose if you make this kind of an error, you say okay fine, cannot perform A plus B. You go over here, you make this P Q R, and the error stays. It says cannot perform P plus B. So it does not have any problem with the name. It has the problem with the derivative. It can't add the derivative. The name is okay. You can name it A, B, C, P, Q, R. No. All your neighbors pet dog. Right? So that does not matter. Fine. What matters is the derivative. It can never add these types. Because you can't understand how to add these types. It can basically add only predefined types. So you see, again, on the other hand, if I again write the same statement, how do you know that this will happen? Because if you have written only A and B, if you cut out A, what is the data of A? Inbox. See, size 5 is also not important. Why? Because size 5, 10 does not matter. It won't be able to happen. Got it? So how do you know that the expression that you are writing is wrong? If you have used A and B, so cut A. What is A? If you cut A, you know what is A. Inbox. If you cut B, you know what is B. Inbox. Just like if you cut A, you know what A is. Int. Just like if you cut B, you know what is B. Int. So similarly, if you cut A is inbox. If you cut B, it is inbox. And it cannot add inbox plus inbox. It cannot perform. Fine. So suppose if I write int a box 5, b box 5, c box 5, and if I write c box 0 equal to a box 0 plus b box 0, from your experience you know that this will work, because we are basically adding the first element of the first array with the first element of the second array and placing it in as the first element of the third array. This should work. Now how will we know while writing the expression without any experience and all, how will we know that this will actually work? You see, you have written in a box, you have written in a box. So what is in a box? What is a box 0? You have written a box 0. So what is a box 0? If you cut out a box, what is left? In. So basically this is in plus in. So that is the cut out rule. If you cut b box, what is left? In. So in plus in. So user defined types are composite type. You know, they are composite type, complex type. We have enzymes, right? We have enzymes which breaks down complex, food particle into simple food particles so that we can digest. So for every complex type that we have in the language, we have a supporting enzyme as an operator. When you mention A, it is the actual complicated complex type, which the compiler can't digest. But when you mention box, from the complex composite type, it comes down to the simple int type, which the compiler can digest. So for arrays, we have the box operator. Similarly, for pointers, we have the star operator. How? Suppose if I say int star a, star b, star c. So tell me something. Suppose if I write c equal to a plus b, will this work? This will never work. How do you know before that? If you cut out a and b, it goes like this: int star plus int star. You can never add two addresses. Right? You can add only two integers. So int star plus int star will never work. Right? But suppose if I write so if I am writing star a and star b. So if I cut out star a, it is int, and if I cut out star b, it is int. So int plus int will work. What is the concept behind it? When you are saying a plus b, you are basically trying to add the address content in a and the address content in b. So two addresses can never be added. Whereas when you are saying star a plus star b, then you are fetching the value of the point b. A is pointing to suppose p and b is pointing to suppose q. So star a means value of p and star b means value of q, and p and q are integer variables. So they contain integer values. So you are basically adding two integers. That will work. Getting it? So right when you are right at the point of time when you are creating the expression or putting the expression, this is a fantastic technique that allows you to test or verify the expression that you are writing by checking the reader, whether the reader will work, whether for that particular reader it will work or not. Are we clear? Understood? So you can copy it if you want. order of derivative. First order derivative, second order derivative, third order derivative. Right? So the rule remains same. The basic rule remains same. The order increases. And when you integrate, the order again comes back to the previous one. So n plus 1 order when you are differentiating, and n minus 1 order when you are integrating. Fine. Now, so it is pretty simple. And similarly, pointer to pointer is also very, very simple. That is, you either you increase the order or you decrease the order. Now you see, if you have a normal variable whose address you are interested in storing in another variable, then you require a pointer variable. Now the pointer variable itself is also another variable. So, and just like any other variable, the pointer variable itself will also contain an address. Right? So suppose if I say that A is